When you actually look around at the physical world, the infrastructure that keeps everything moving is, well, it's completely obvious.
Oh, yeah, you literally can't miss it.
Right, you see the massive cargo ships in the harbor, the freight trains stretching for miles, the 18-wheelers just dominating the highway. But when you look at the global economy today, the truly critical cargo isn't sitting in a shipping container.
No, not at all. It's entirely digital.
Exactly. It's healthcare claims containing incredibly sensitive patient data. It's multi-billion-dollar financial settlements moving between central banks. Or global supply chain manifests dictating where thousands of physical parts need to be by tomorrow morning.
And the infrastructure that moves all of that data is completely invisible to the naked eye.
Completely invisible and bearing an unprecedented amount of weight.
Yeah, I mean, if that invisible infrastructure fails, the physical cargo ships literally stop dead in the water. The banks can't settle their daily ledgers.
Right.
Hospitals can't process patients or get reimbursed. The entire system just grinds to a halt.
Which is exactly why we are dedicating today's deep dive to pulling back the curtain on enterprise data movement. Welcome in.
Glad to be here.
So both of us live and breathe this architecture every single day. We work at B-Trade, focusing entirely on data security and managed file transfer, or MFT. We spend our lives engineering and analyzing how to keep this digital cargo moving securely.
We do, and we're bringing you a very specific insider's perspective today on the DNA of modern MFT platforms.
And to anchor this discussion, we're analyzing a phenomenal architectural blueprint written by our Chief Technology Officer here at B-Trade, Andre Olin.
Yeah, Andre he's brilliant. He spent decades designing mission-critical platforms for global heavyweights.
Places like Merrill Lynch and Deutsche Bank, right?
Exactly. And the architecture he outlines moves us far beyond the legacy mindset of, simply opening a network port and blindly tossing a file across the internet.
We're going to explore the specific layers that make secure, scalable, and observable file transfer possible today. We aren't just looking at the surface. We are going to really break down the mechanics.
How you defend the perimeter, how you orchestrate internal routing, all of it.
Right. How do you bypass incredibly stubborn firewalls safely? And how do you maintain visibility when you're moving terabytes of data across the globe?
It's a massive undertaking.
It is. And to understand how data moves, we first have to understand how we let it in safely. Because in a modern threat landscape, you cannot just leave the front door open and hope for the best.
No, absolutely not. Granting immediate direct access to a core internal network is basically the quickest path to a catastrophic security breach.
Yeah, it's game over.
That is why the first critical component Andre outlines is the secure gateway layer, which operates hand in hand with a robust security and identity layer.
Okay, so the gateway.
Right. The primary function of this gateway is to act as the absolute boundary. It sits in a segregated edge network, what network engineers call the DMZ.
Okay, let's unpack this with a visual, because I always like to think of this secure gateway layer like a highly secure embassy located on foreign soil.
Oh, that's a good way to look at it.
Yeah. So if you're a visiting diplomat, which in our scenario is a trading partner trying to send us a crucial financial file, you don't get to walk right into the capital city and access the inner sanctum of the government.
Right, you'd be stopped immediately.
Exactly. You go to the embassy first, the embassy intercepts you, and its job is to terminate your journey right there at the perimeter.
And the technical mechanism for that interception involves terminating network sessions.
Meaning what, exactly?
Well, when a partner connects using protocols like SFTP, FTPS, HTTPS, or AS2, the gateway stops that connection at the edge. The external traffic never touches the internal processing systems directly.
Let's actually define that alphabet soup for a second, because the choice of protocol matters immensely for the security layer.
It really does.
Like, if a partner is using AS2, for example, which is a specialized protocol built specifically for secure business-to-business corporate data sharing, they aren't just sending data.
No, AS2 has built-in cryptographic mechanisms. It provides electronic delivery receipts, proving the file was received and wasn't tampered with.
Right. And if they're coming in over SFTP, the security layer is rigorously checking SSH keys.
Which are essentially complex cryptographic locks that are vastly superior to a simple password.
Way better than a password. And beyond checking those cryptographic locks at the door, the identity layer is enforcing granular role-based access control.
Yeah, even after a partner successfully authenticates, the system enforces strict partner isolation. I mean, they can only see the exact virtual directories they are explicitly permitted to see.
And the data itself is protected by strong encryption for data in motion. We frequently deploy optional file-level encryption as well at Btrade, like OpenPGP.
which acts as a secondary layer of armor. Even if someone somehow intercepted the file in transit, all they would see is scrambled mathematical noise without the corresponding private decryption key.
It's basically useless to them.
Exactly.
There is a vital operational detail Andre includes here regarding certificate lifecycle management, or CLM.
Oh, this is huge.
Because a digital certificate is basically a digital passport with a strict expiration date. And I cannot tell you how many massive headline-making enterprise outages happen simply because a single digital certificate expired on a Friday night and literally nobody noticed.
It happens all the time. But a modern architecture prevents that by automating the entire life cycle. This system actively polls certificate authorities, monitors for impending expirations across all trading partners, and it triggers automated renewal workflows well before the expiration date.
So no Friday night panic.
Right.
Yeah.
It ensures that secure communication channels don't just suddenly collapse because of administrative oversight. And furthermore, to ensure that Embassy never closes its doors, the architecture utilizes multiple gateway nodes deployed behind load balancers.
So if one gets overwhelmed,
The load balancer dynamically routes the traffic to healthy nodes. It ensures high availability and seamless horizontal scaling.
got it. So the gateway securely catches the data at the edge. The diplomat is inside the gates, their credentials have been verified, and the encrypted briefcase has been handed over.
Safe and sound.
But the file doesn't just magically arrive at its final destination deep inside the corporate network. It needs direction. It needs processing.
Right.
Which brings us to the engine that actually drives the workflows, the transfer orchestration engine.
Yeah, we have moved completely beyond simple point-to-point transfers, where server A simply pushes a file to server B.
It's so much more complex now.
It is. Modern platforms, like our own TD Exchange at Btrade, are responsible for coordinating incredibly complex, multi-step operations. An orchestration engine handles ingestion from the gateway, performs validation to ensure the data isn't corrupted, executes data transformation, handles internal encryption, and finally manages delivery.
And it can be delivering to potentially dozens of different internal and external destinations simultaneously, right?
Exactly.
Now, here's where it gets really interesting and where I've seen organizations stumble. I've had conversations with IT directors who ask, why do we need a massive dedicated orchestration engine for this? I have a team of developers who could just write some Python or shell scripts to grab a file from a directory, encrypt it, and drop it where it needs to go.
I hear that argument constantly. But scripts are fundamentally fragile when introduced to enterprise-scale complexity.
Because they lack context.
Exactly. They lack what Andre refers to as state awareness.
Let's break down the mechanics of state awareness, because a basic script is essentially, well, it's like a golden retriever playing fetch.
Okay, I like this.
You throw the ball, the dog runs, grabs it, and bugs it back. But if someone closes the door to the yard while the dog is running, the dog just smashes into the door and stops.
Right, it doesn't know how to open the door.
It doesn't know why it's fetching, it doesn't know who to call for help, it just executes a rigid command.
And that lack of context is disastrous in a mission-critical environment. A script doesn't inherently understand dependency management, it doesn't have sophisticated retry policies, and it completely lacks conditional routing.
Let's apply this to a real-world scenario Andre highlights in the blueprint, healthcare claims processing.
A perfect example. These operations are governed by strict service-level agreements, or SLAs. Let's say a hospital network has a strict SLA that requires a massive batch of Medicare claims to be transmitted, processed, and acknowledged by 11:59 p.m. on a Friday.
The clock is ticking loudly, and millions of dollars in reimbursements are on the line.
Exactly. If you're relying on a script to move those claims, and the destination server on the government side experiences a momentary hiccup at 11:30 p.m., the script likely just fails.
It just crashes into the closed door.
Right. It encounters an error, stops, and quietly writes an error code into a text log file on a server somewhere. The IT team won't realize the file didn't arrive until Monday morning.
Oh, man. And by then, the submission window has closed.
The SLA is breached, the reimbursements are delayed, and the financial penalties are locked in.
But a state-aware orchestration engine fundamentally changes that dynamic through flow-level SLA tracking.
It does.
An engine like TD Exchange knows exactly how much time a specific workflow is supposed to take from start to finish. It's actively monitoring workflow timestamps, transfer completion metrics, and inbound acknowledgments.
It acts proactively. So if that Medicare workflow is approaching its SLA threshold at 11:15 p.m., and the engine hasn't received a successful delivery acknowledgement, it doesn't just wait to fail.
What does it do?
It triggers automated high-priority alerts to the operations team before the failure occurs. It attempts intelligent retries or reroutes the data through a backup connection. It manages the complexity and enforces the business logic dynamically.
It takes the burden of constant manual monitoring totally off the operations team.
Absolutely.
Now, orchestration handles all of that internal routing beautifully when all our systems are playing nice and can talk to each other. But we have to look at what happens when we hit a rigid network wall.
Ah, yes. The firewall problem.
Right. Let's say we need to exchange data with a highly secure manufacturing facility or a remote branch office. Their security team has a strict policy: absolutely no inbound connections allowed. They will not open a port on their firewall for you, regardless of how secure your gateway is.
This is one of the most stubborn networking roadblocks in enterprise IT. You have a rigid internal firewall, and the security team's mandate is zero inbound traffic to protect the manufacturing floor's operational technology.
And you cannot force them to change their firewall rules.
Never. Which necessitates the third layer of Andrea's architecture, agent-based connectivity.
I love the mechanics of this solution. I like to think of the MFT agent as our trusted inside man.
An inside man.
Right. Imagine you need to get a message to someone inside a heavily fortified bunker. You could spend days trying to punch a hole through their reinforced steel front door, which is the equivalent of trying to force a network engineering team to open an inbound firewall port.
And they will fight you every step of the way to protect their perimeter.
Exactly. Instead of attacking the perimeter, you deploy a lightweight software service, the agent, right inside that secure environment, adjacent to the system that is generating or consuming the files.
And then the inside man simply picks up the phone from the inside and makes a secure outbound callback to headquarters.
Headquarters being the central MFT platform.
Exactly. The elegance of this approach lies in how it respects existing security postures.
Right, because firewalls treat outbound traffic differently.
Yeah, the vast majority of corporate firewalls are configured to block inbound traffic, but will allow secure, authenticated outbound traffic on standard ports. By establishing an outbound encrypted polling channel, the agent bridges the unbridgeable gap without requiring a single inbound firewall rule change.
It perfectly aligns with zero-trust communication models.
It really does.
And these agents are far more than just dumb network pipes. Once they establish that outbound connection, they take on significant local responsibilities.
Right, as Andre outlines, they can actively monitor local directories on the manufacturing floor. When a machine generates a new diagnostic file, the agent immediately detects it, encrypts it locally, and pushes it up to the central platform.
Wow, so it's doing the prep work before it even sends it.
Exactly. They can also execute pre- and post-processing scripts locally. If a massive database extract needs to be compressed or converted into a different file format before it is transmitted over a limited bandwidth connection, the agent performs that heavy lifting right there on the local server.
Which is vital for hybrid cloud integrations.
Very much so. It seamlessly bridges the gap between legacy on-premises systems and modern cloud workloads, all while maintaining centralized control and visibility.
Now, that visibility becomes paramount as we move into the fourth section of the architecture. Getting through the firewall is one thing, but simply moving the data isn't enough when you're dealing with multi-gigabyte or terabyte scale data sets.
Not even close.
You need to ensure it's moving at maximum velocity, and you need to be able to see exactly what is happening inside the pipe. This requires a deep understanding of transfer observability and acceleration.
Because large-scale data movement introduces serious physics problems.
Wait, physics problems? Are you talking about the actual time it takes light to travel through fiber optic cables across the Pacific Ocean?
That is exactly what I'm talking about. We have to look at how traditional protocols function over long geographical distances. Take a standard protocol that relies on TCP, Transmission Control Protocol.
Okay.
TCP is fundamentally a conversational, chatty protocol. It requires a receipt. It sends a packet of data and then it pauses, waiting for an acknowledgement from the receiving server before it sends the next packet.
And when you're sending data from a data center in Dallas to a partner in Tokyo, there is physical latency.
Huge latency. The time it takes for that acknowledgement packet to travel back across the globe compounds. Even if you have a massive multi-gigabit internet connection, TCP windowing limits your speed because the protocol itself is hitting the brakes, waiting for receipts.
So the pipe is wide, but the data is just trickling through.
Exactly.
That is incredibly frustrating for an enterprise paying a premium for high bandwidth links, which is why modern architectures incorporate specific performance optimization mechanisms to bypass those limitations.
Right. Andre highlights solutions like TCP window tuning, which allows more data to be in flight before requiring an acknowledgement, and parallel transfer streams.
Parallel streams, meaning it breaks a massive file into smaller chunks and sends them simultaneously.
Exactly. But more aggressively, systems will utilize UDP-based transfer acceleration. UDP user datagram protocol does not wait for those constant acknowledgments in the same way TCP does.
So it just fires the data off.
Yeah, it acts as a fire and forget mechanism, allowing organizations to blast massive data sets across high latency transcontinental links at speeds that actually utilize their full network capacity.
But what if something goes wrong mid-transfer?
That's where checkpoint restart capabilities come in. If a 2 terabyte database backup transfer drops at 99% completion due to a network blip, the engine resumes from the exact point of failure rather than starting the hours-long process all over again.
That is a lifesaver. So with data moving at those blazing speeds, agents firing off in hybrid clouds, and orchestration engines juggling thousands of concurrent SLAs, the operational environment sounds overwhelmingly complex.
It is.
And Andre heavily emphasizes observability to manage this. But we need to clarify what that actually means, because IT systems have been spitting out log files for decades. But a log file is not observability.
No, relying on logs to manage a global data supply chain is a recipe for disaster. Think of the mechanics here. A log file is entirely historical. It's a text record written after an event has concluded.
Right. Relying on logs is like finding out you broke your ankle only after you finished the marathon and took your shoes off.
That's a brutal image, but accurate.
It tells you what went wrong, but the damage is fully done. True observability is a central nervous system. It's a live telemetry network, constantly sending health and pain signals to the brain, the orchestration engine, so it can adjust its stride in real time.
Exactly. Advanced telemetry provides live visibility into active transfers, fluctuating throughput rates, retry behavior, and partner responsiveness.
It's a live MRI, not a postmortem.
Right. Instead of a system administrator manually parsing through thousands of lines of text trying to correlate a failure, platforms like TD Exchange integrate this telemetry directly into a centralized dashboard.
So they can see the problems forming.
Operations teams can detect a TCP throughput bottleneck forming in real time. They can see if a specific trading partner's endpoint is experiencing a micro outage and automatically reroute critical traffic before an SLA is breached. It shifts the entire IT posture from reactive troubleshooting to proactive optimization.
It's a totally different way of managing infrastructure. Well, we've covered incredible ground dissecting Andre Olin's architectural blueprint today.
You really have.
We started at the perimeter, establishing that secure embassy in the DMZ with the secure gateway layer and robust identity verification. We moved inside to the transfer orchestration engine, which acts as the state-aware brain managing those complex SLA-bound workflows.
Then we explored how agent-based connectivity acts as our inside man, gracefully bypassing stubborn inbound firewall restrictions without compromising security.
And finally, we looked at how real-time observability and UDP acceleration give organizations the sight and speed necessary to manage terabyte-scale data movement across the globe.
And it is critical to recognize that this architecture is highly adaptable. Andre points out that organizations can deploy these platforms completely on-premises to satisfy strict data residency regulations. They can utilize hybrid models to connect legacy infrastructure to modern cloud applications.
Or they can consume this entirely as managed MFT services where the infrastructure overhead is handled by experts.
Exactly.
Yeah.
Platforms like TD Exchange operate seamlessly across all these models, allowing enterprises to modernize their data movement without disrupting their existing, deeply entrenched global operations.
This invisible infrastructure impacts you, the listener, every single day. Whether you're swiping a credit card at a terminal, waiting for a critical manufacturing part to arrive at a factory, or relying on a healthcare portal to process your medical history, you are depending on this resilient, highly secure data movement to function flawlessly.
And as we look at the trajectory of this technology, Andre's blueprint raises a profound question about the future of enterprise architecture.
What's that?
Well, if modern MFT orchestration engines and remote agents are now executing complex local scripts, performing heavy data transformation, bridging hybrid clouds, and strictly enforcing granular zero-trust security models across global boundaries, are file transfer architectures actually evolving into decentralized data operating systems? We're rapidly blurring the line between simply moving a file from point A to point B and actually computing, transforming, and securing data dynamically across the entire global supply chain.
Whoa. That is a massive paradigm shift. The network isn't just the highway anymore, it's becoming the processing facility itself.
Exactly.
It completely redefines the value of that invisible infrastructure holding up the global economy. Next time you think about your data moving securely, remember the complex, state-aware engine humming away behind the scenes, adjusting its stride in real time. Until next time, keep diving deep.